Hi everyone, I am Dr. Peiris. Today I am going to show you how to graph exponential functions. So what are the topics that I am going to explain you today? First I will define the exponential function. Then I will show you the characteristics of the parent function when the base b greater than 1. Then how to graph the exponential function when the base is greater than 1. So similarly I am going to discuss the characteristic of the parent function and how to graph the exponential function when the base is a fraction in between 0 and 1. So what is the general form of an exponential function? So for any real number x, an exponential function is given by this relationship. F of x equals ab raised to the x power. A is called as the initial value and both a and b are real numbers. A is not equal to 0 and the b is also not equal to 1. So these conditions must be satisfied to have an exponential function. And the parent function for this exponential function is given as b raised to the x power. So in this video I am basically talking about this parent function, how to graph the parent function. And then I will have another videos showing the transformation of this parent function and then how to do the transformation graphs. So let's see what are the characteristics of parent function when the base b is greater than 1. So the parent function is given as f of x equals b to the x when b greater than 1. So here we discuss what happened when b greater than 1. So to graph any exponential function or any other function, we need at least 3 points to see how the function changes with negative x values and the positive x values. So you can choose any 3 values, but to make it simple I used x values negative 1, 0, 1. So we have the negative x values, a 0 as well as a positive x value. So now let's go and substitute for the x. So this is b raised to the x power. So we substitute x equals negative 1 in the first one. So which means it becomes b to the negative 1. B to the negative 1 is 1 over b. And the next one, x is equal to 0. So b raised to the 0th power. So we know that any number raised to the 0th power is equal to 1. The b to the 0 is equal to 1. Then the x equals 1. So we substitute here, b raised to the 1 is equal to b. Now we have at least 3 points, so we can make a graph. So the first point is at negative 1, 1 over b. So here is the point negative 1, comma 1 over b. The second point is 0, comma 1. Here is 0, comma 1. And then the third point is 1, comma b. 1, comma b. Since b greater than 1, so this is how it looks like when you plot the 3 points. And when we connect these 3 dots, this is how the exponential function look like. So this function is increasing as the x increase, as well as this is a one-to-one function. It passed both the horizontal and the vertical line test. So this is a one-to-one function. And if you choose more x values on the negative x-axis, you will find that the x values decreases and then it is approaching to 0. But it never be equal to 0. Which means that we have horizontal asymptote, which is y equal to 0. So the horizontal asymptote for the parent function is y equal 0. And the domain, so no restrictions for the x values that we can substitute for the exponential function. You can substitute any x value in this given function, which means the domain is going from negative infinity to positive infinity. And what would be the range? So we see that no there are no y values in this function. So all the y values reach to 0 as we decrease x. So which means the domain is from 0 to infinity. And the 0 is not included because the function value will never be equal to 0. So that is why there is a parenthesis from 0 to infinity. The 0 is not included in the range. And do we have any x-intercepts? There are no x-intercepts. This function never crosses the x-axis because it reaches to 0. And the y-intercept is at 0, 1. So these are the basic characteristics of the parent function when the b is greater than 1. Now let's make some graphs using the things that we learn in here. So we're going to graph the function f of x equals 3 to the x. So always we need to choose at least 3 points and then find the corresponding y value, so we can easily draw the exponential function. So I prefer to use -1, 0 and 1 because it is very easy to do the math when you do the calculations. So let's go ahead and substitute these x values in this given function. The f of x equals 3 to the x. So the first one is x equals -1. So we go and substitute x equals -1 in here. So this is 3 to the -1, which is basically 1 over 3. And then the next one, x equals 0. So 3 raised to 0 is equal to 1. The third one is 3 raised to the 1, which is equal to 3. So this follows the same pattern, 1 over b, 1 and b, as I explained in the parent function. So now we can go and plot these points. So the first point is at -1, 1/3. So -1, 1/3 somewhere here. And the second point is 0, 1, 0, 1. The third point is 1, 3. So this follows the same pattern as in the parent function, and then when we draw we have to make sure that we don't touch the x-axis because this will never equal to 0. The left side is basically reaching to 0, but it never be equal to 0. So you have to make sure that you don't touch the x-axis or we don't cross the x-axis. This is the horizontal asymptote at y equals 0. So this is how we graph the parent functions. Very simple. Let's see another example. So here we're going to graph f of x equals 5 to the x. So it's the same procedure. Substitute x equals -1 in the first one, 5 raised to the -1, which is 1 over 5. Second one, x is equal to 0, so 5 to the 0, which is 1. Third one, x is equal to 1, 5 raised to the 1, which is 5. So the 3 points, -1, 1/5, and the second point 0, 1. So always we're going to have this point 0, 1 because that is the y-intercept for any exponential function if we are talking about the parent function. The third one, 1 to the 5th. So it's the same pattern, increasing function, and it goes like that. So this is the exponential function when the base b is greater than 1. Now let's see what are the characteristics of the parent function when the b is between 0 and 1. So when the b is between 0 and 1, we do the same analysis. When x equals -1, we substitute b equals -1. So what's the difference in this case? So b equals -1 is equal to 1 over b. If the b is between 0 and 1, which means b is a fraction. So if it is a fraction and if we do 1 over, or if we find the reciprocal of a fraction, it becomes a value greater than 1. For example, if the b is equal to half, if I do 1 over half, it becomes 2. So this 1 over b value is a value which is greater than 1. So that is why it is up there. It is a value greater than 1. It is going to be above this 1. So it is plotting over here. And the next one, x equals 0. So b to the 0 is 1. So again it's the same y-intercept at 0, 1. The third one, x equals 1. So b raised to the 1 is equal to b. But now this b is between 0 and 1. So it is a value which is less than 1. So that is why 1, b point is here. It is less than 1 value. So this function is decreasing. That's the only difference compared to the previous case. The function is decreasing. Still it's the same other characteristics. It's a one-to-one function and the function is decreasing, approaching to 0, but it will never be equal to 0. So here is the horizontal asymptote at y equals 0. The domain is negative infinity to positive infinity. The range starts from 0 and then it goes to positive infinity. So the range is from 0 to infinity. Again, the 0 is not included. And no x-intercepts. This would never cross the x-axis. The y-intercept is 0, 1. So it's a very similar pattern, similar characteristic, except that the function is decreasing. Now let's see some examples. So f of x equals 1/3 x. So you see that the b is equal to 1/3, and which is a value in between 0 and 1. Now let's substitute these values and then obtain the y values. So we're going to do x equals -1 for the first case. So substitute x equals -1. 1/3 to the -1. So 1/3 to the -1 is equal to 3 because of the negative exponents. And then 1/3 to the 0. Anything raised to the 0 is 1. Then 1/3 to the x is equal to 1. So which is equal to 1 over 3. Now let's plot the point. So the first one is -1, 3 right here. Second one is 0, 1. 0, 1 goes here. 1, 1/3. So 1/3 is a value which is less than 1. So we must put it somewhere here. And then we connect the dots. The function is decreasing and approaching to 0. But it will never touch the x-axis or cross the x-axis. This is how we do when the b is between 0 and 1. Let's see another example. Very similar. F of x equals 1/5 raised to the x. So here the b is 1/5. Now let's substitute the values. 1/5 x is equal to -1. 1/5 raised to the -1 is 5. 1/5 raised to the 0 is equal to 1. 1/5 raised to the 1 is equal to 1/5. So the first point is -1, 5. And the second one is 0, 1. Third one is 1, 1/5. 1/5 is less than 1. Very close to 0, 1/5. And we do the same thing. We draw the curve. And remember that the horizontal asymptote is at y equals 0. So your graph should not cross the x-axis. So this is how we simply graph the parent functions depending on the value of the b. So that's all for today, everyone. And I will have more lectures on this topic about how to do the transformations of exponential functions. So please subscribe to my YouTube channel for all the videos and visit my website www.drpeirisclassroom.com. Thanks for watching, everyone. I'll meet you again with another video.